Okay, so let's do a quick overview of tree diagrams. So a tree diagram is just a more visual way of representing a lot of data, specifically when you're having two different branches. So like, for example, if we're combining, finding somebody's blood type, we can go by their 4 basic blood types and then whether they're positive or negative. So we can make our sample space and say they could be blood type O positive, O negative, A positive, A negative, and so on. So we can use the tree diagram to visualize our sample space, but we can also use the tree diagram to apply probabilities and then answer some questions. And so what we're going to do is on these branches, we're going to put the individual probabilities, and then we're going to add some more. As you add the probabilities, all of the branches vertically down should add to 1. So these guys should add to 1, these guys, right? These guys are going to add to 1. As we move across, we can multiply the probabilities. So we take this probability times that probability, and I'm going to add one more number here, one more branch, and this is our AND probabilities. If you multiply, or if you add all of these guys together, they'll add to equal 1. So let's see how it works out with this first example. So this has a volleyball player has sustained a rotator cuff injury and is deciding if she should have surgery, S, to repair it, or if she should do physical therapy. So that's the first decision, right? So when we make our tree diagram, we have a starting point. The first decision, the first choice is whether we should have surgery or do physical therapy. Then it says her doctor states that prior data suggests that 0.85 probability that the patient will select surgery. So notice that selecting surgery has a 0.85 probability of selection, which means if these need to add to 1 minus 0.85 is 0.15. So this covers 100% to like these are the only 2 options. So our choice is going to be just between those 2, so these should add to 1. After you choose surgery or physical therapy, then we start looking at whether or not she can resume normal athletic activity within 4 months. So that's the second data point we're looking at. So it says that if she does select surgery, there's a probability of 0.7 that she will be able to resume all athletic activity. So we'll call that A. So in the tree diagram, you see if we select surgery, she will be able to resume all athletic activity, A, with a 0.7 probability. So notice that 0.7 is if we choose surgery, then she can resume it in 4 months. But there's another chance. She could have the surgery and then she could still be in pain or whatever, it didn't fix it, and she won't be able to resume normal activity in 4 months. And so that's the other option, the complement. And so if these have to add to 1, if this is 0.7, this is 0.3. So when we continue reading, if she chooses physical therapy, there's a 0.2 probability of resuming physical activity, so 0.2, which leaves this as 0.8. So the blue and the purple here show us just how we're organizing all that data that the problem gave us. But then we're going to go one step further and multiply each branch. So 0.85 times 0.7 is this. 0.85 times 0.3 here. 0.15 times 0.2. 0.15 times 0.8. And if we add all these together, we get 1. Now, it's important to do this step because this is all of our AND probabilities. So once we've organized our data and we got all of the probabilities, then we can answer a lot of questions. Notice one of the main questions we're looking at is we look at this conditional. So find the probability that we can resume athletic activity given that we had surgery. So notice that the condition tells us which path, which branch to follow. So given that we had surgery, what's the probability that we can resume normal activity? 0.7. The next one, what's the probability that we can't resume normal activity given we had surgery? So given we had surgery, go down that path. What's the probability that we can't? 0.3. And very similar with physical therapy. So what's the probability we can resume physical activity given physical therapy? So now it says go down this branch. What's the probability we can resume activity? 0.2. Probability we can't resume activity? 0.8, right? So notice the notation tells us which branches to go down. The trickier ones here is when we're looking at, so this was conditional probability. What happens if we're looking at like the general probability? So what's the probability of just being able to resume athletic activity, right? If you're the volleyball player, you're like, listen, I just need to know for my sanity, like, am I going to be able to play again in 4 months? And the doctor's like, well, you have 2 different choices. You'll be able to resume physical activity with the surgery, or you'll be able to resume physical athletic activity with physical therapy, right? So there's two ways you can get your desired outcome of being able to resume physical athletic activity. One is with surgery, so and the 0.85 times the 0.7, which is 0.595, or with physical therapy, right? So physical therapy, and you can do it. So if we multiply these guys, we get the 0.03. Both of these scenarios will get us what we want, either this or this. So in general, the probability that we'll be able to resume activity is 0.625. So notice for this guy, there are these two together will allow us to reach our desired outcome of resuming physical activity. We can do the same thing with this guy and say, okay, what if we can't? What's the probability that we won't be able to resume athletic activity? Well, there's two cases here with surgery and we still can't, or physical therapy and we can't resume. So we add those two together. So these are trickier when you're looking in general. Okay. So based on the calculations, would we recommend surgery? Well, we can look at the probabilities here. So athletic activity with surgery is 0.7. Athletic activity with physical therapy is 0.2. I would recommend the surgery. We have a higher probability of being able to play after 4 months. And then there's two other questions. If, which remember is our key word for conditional probability, if a patient has achieved event A, right, that they can play again. So given A, that they can play again, what's the probability that they had surgery? So to rewrite this sentence in conditional notation, what's the probability that we had the surgery if we're playing again after 4 months, right? So the phrase that follows if is your condition. So even though in the sentence it's written first, the condition's always written second in the notation, and that's what goes in the denominator. Notice we needed this probability of just being able to play that we calculated up here. We had to do that on our own. That's our denominator. And then the probability of and surgery and athletic, we look here, here's that and surgery and athletic activity, the 0.95. So we can use the conditional probability formula along with our tree diagram to grab the decimals that we need. And the same thing if we have not achieved the desired event A, meaning we can't play again after 4 months. So if that's the case, what's the probability that we did physical therapy, right? This is the condition. That's the probability that goes in the denominator. And then the joint probability, the and, goes in the numerator. So notice this probability, the probability that we're not playing again after 4 months that we calculated up here is 0.375. And then the probability of physical therapy and we still can't play. Physical therapy and we still can't play. Remember, we multiply these two together to get this guy. That's our numerator. So this is the probability of that question. Okay, so notice it's very similar formulas, conditional probability, or probability, all that stuff. But now our proportions and our probabilities are all organized in a tree diagram, which makes it easy for us to find what we need. All right, we'll discuss more in class. Have a great day, guys.